Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about USB high speed in 2026, the mess that we are dealing into. So what exactly is the problem? Well, problem is there are way too many USB standard, like way too many, and all of them are parallelly active. So it's not like back in the day it was that and this is no, all of them are active right now. So that creates an issue. And for some reason, USB implementers forum, and be mindful, almost everything has a forum. So there is a Bluetooth forum, there is a SD card forum. So there are always a forum of whenever something becomes what you call consumer grade, it creates a forum so it can be monitored and evaluated, so to say. So they smoked something good. They became too high and they created stupid name. Be mindful, they have engineering name and they have a name like normal name, but for some reason they are like, what if we had engineering BS name? Because again, engineering name changes based on the technology term. You do not want that to reflect into your basically product name. So you must have seen some products have like a weird long chain. Those are engineering number, not names, but sometimes they do that. So naming was stupid from day one, and then they really went high and they are like renamed old standard, and they did that 2 times. So for example, USB 3.0, sweet name, simple, logical, elegant, and it was a quantum leap. Basically, USB 1.1 to USB 2.0 was not that big of a deal. It was just like good. But USB 2.0 to 3.0 was like, whoa, like, whoa. Like that link was so fast that it exceeded what hard disk drive could do. And be mindful, this is 2010. So hard disk drives were, well, they are still used. So if you had bought something like this, it was like, bro, I can utilize full of its full use, but the interface will still have more than enough bandwidth left. So that was awesome, nice. And they're like, what if we smoke? And what if we renamed something that is already made, shipped, people are using it for years? What if we rename something that already exists into USB 3.1 Gen 1? Why there are so many ones into this? And why the name is so long? USB 3.1 Gen 1. Why? Okay, cool. Then they renamed it again. USB 3.2 Gen 1. Why there is 0.2? Speed is same, by the way. Speed is exact 5 Gbps. Basically, exactly what you could have gotten, like what my ancient motherboard had is the same thing. But again, that because it's an ancient motherboard, it has printed USB 3.0. And now if you buy same motherboard, again, it's not manufactured anymore. If you bought the same one, it will have to rename, the box art has to be updated to USB 3.2 Gen 1. Why? Although, let that be very clear, somebody must have bitch slapped them and they're like, okay, at least for cable and port, not for naming, but at least cable and ports, we're not gonna smoke cocaine, we're gonna be logical. So we're gonna just say either it's 20 Gbps, 5 Gbps, or 40 Gbps. We're not gonna do anything. So we're gonna have two ratings, your wattage and your data speed, nothing else. I'm like, thank you. And please pass me the supplier. What were you smoking? I'm like, 3.0 became 3.1 to Gen 1 and 3.2. Same thing. How the heck that happened? And there was USB 3.0, 3.1. Then it became 3.1 Gen 2. And then it became 3.2 Gen 2. That was like 10 Gbps. Okay, cool. Then they have like 3.2 Gen 2 X2. By the way, speed did not change. It was just a different protocol architecture. And then USB 4, which is 20. Like, somebody stopped them. Again, these things were actually shipped to public. It was not like, okay, oh, back in the back end. No, they were sold in the public. It was there. It's like, bro, accept it and move forward. And I have no idea. Whenever they were jumping from basically speed to speed, as in like 5 Gbps, 10 Gbps, why the heck 10 Gbps did not get its full number? It's like, bro, you double the speed again. It's like PCI coming from PCI 3.0 to PCI 3.1.5. It's like, what is smoking? Like, look at PCI. It's always that PCI association. Hey, 3, 4, 5, the end. No BS. You are doubling the speed, double the numbers. PCI, USB 3.0, 4.0, 5.0, 6.0. Everybody will easily understand which number you have. That means whether you are faster or slower. The end, you do not have to worry about it. But no, but at least this is somewhat useful because the number is still there. So even if you do not know what Gbps means, you will like, okay, 5 is smaller than 20, 20 is smaller than 40. You will inherently understand that. And if you're like, hey, the port says 20, basically the cable says 20 and the motherboard has etched 20, you put 20 to 20. So that is there. And be mindful, why those numbers are so huge, even though you never see this speed, is because interface is always measured in bits, BIT, basically on or off. So that is denoted by small b. So these things are gigabits per second, bit small b. But whenever you are seeing the file and transfer speed, those are measured in bytes. Like that 8-bit makes a byte, that byte. So whenever I say USB 3.0, that simply means 5 Gbps and 625 megabytes per second. So let that be those numbers, the big numbers, divide them by 8. That's what you have actual, like that's what you will see when you are transferring file. So, and your speed will be limited by the slowest chain. For example, again, this is a very good example. It had like people were like, hey, I bought a USB 3.0. I'm talking like long ago, like 10-15 years ago. Damn, I'm old. People used to complain a lot because again, the box spec will say USB 3.0, like, 625 Mbps, and they will try to get that speed. Some people tried to actually dump data into like, RAID array, and it was still not getting this. Like, why? It's like the spinning drive is the same. They did not invent a high speed drive, like, spinning Rust, so to say. Oh, there are, but they rotate at 15,000 RPM, used in servers, have very short lifespan, so they are not suited here. So people were a bit too optimistic. So, although, let that be clear, that being said, this was created basically, hold on. What the hell? Yeah, so same form factor, basically 2.5 inch SSD was created. Now this puppy can actually be utilized. Basically, if I have this can almost go to 80 to 90%, or if very fine tuned, you can even technically touch 600. You will never get 625 because there is a lot of overhead. There is a lot of processing, error correction, things of that nature that you will never get that, but close enough. So be mindful, you are always limited by the slowest thing. It does not matter where that. If your cable is slow, use slow. Your port slow, use slow. Your disk slow, use slow. So this is the problem. And again, at least this is now becoming logical, and I'm seeing this finally trickling down into actual consumer products where cables just have a stamp. Hey, it's a 40 Gbps, 20 Gbps, 80 Gbps, 120 Gbps. Those are coming, but they're not here yet. So you can see, like, please find who was the supplier, what they supplied. Like, you renamed once, twice. Technically, that the 5 Gbps is the third rename. So 5 and 10 Gbps. Now this is a very big jump from USB 2.0. Basically this sort of puppy, because we realized that USB 2.0 can't be upgraded too much, and because it's a backbone connector, meaning everything utilizes this, you do not want to tamper with that. So the idea was created that have extra pins that will be add onto it, basically bolted on top of it, and benefit would be it will work backwards compatible, meaning new device will work with 2.0 port. Yes, slower rate, but it will work. And again, that was a very critical requirement. For example, if my computer has 3.0, I dumped data into this, you should be able to get that data out even on a USB 2.0 system. But yeah, it would be slower, but at least you can get data out. So that was a very intentional choice to add extra contacts. And that was a big jump. Basically, we went to like this sort of speed. This is my SSD based speed test, that is 562. I said, you're not gonna get that 625. Even if it can be done, it's just that it would be too expensive, and who will justify that cost? So if you have any spare SATA 2.5 inch SSD, you can utilize it as like a quality pen drive. I just use it to copy movies from my computer to this TV. Again, there is no other way to get Dolby Vision handshake to happen. So I don't know why, but, and again, it only reads MP4 file, not MKV. Why? So you can do that, and it is same speed as SATA 3. So if you buy any mechanical hard drive, it will always say SATA 3 nowadays, and that is the same speed. So it's very good. You do not need anything more than that if you are dealing with, like, this is a 5 terabyte drive. So you do not need anything more than that. For USB 5 Gbps, you good, you fine. And again, 99% of the time, your computer has that. Like, it's an ancient technology. Like my old computer that was 10 years old had that. You good, you got this. Then if you want to have flexing speed, like really fast, like something like this, 1 gigabyte is achievable for surprisingly low cost. Meaning if you are happy with 10 Gbps, you can buy that, enjoy it very easily. All you have to do is basically buy this and then, hold on, put your M.2 here. NVMe M.2. There are SATA M.2 for some reason, but you have to put NVMe SSD, and then you can easily utilize that speed without any issue, and it's surprisingly cost effective. Unfortunately, AI has doomed us all, so even NVMe cost has become stupid, but you can do that. Surprisingly cost effective. Enclosures are barely 1,000 rupees, like, few dollars, and you can buy a cheap one. You do not need a super fast SSD because again, interface speed is not that fast. So you do not need PCI 5.0. Even PCI 3.0 is overkill. So you can do that. And thankfully, people are like, okay, created two ports. You had port A, which was used in computers, port B, which was for this was for host and that was for device. Port B was for device. So they created the same topology. It's like, hey, what if we take the USB B, which was ubiquitous, and be mindful, European Union had passed the law that that cable port USB B should be utilized by all mobile manufacturers. Everybody followed it except Apple. So they're like, okay, we do not want to throw away that interface. So the idea was we create a fat cable. So this has that fat cable. I can use mobile charging cables, I can use mobile data cables, and this will still work. But again, at 2.0, but if I have the fat one, I can get the full speed. So this is how you got USB 3.0. This was a big jump. Let that be very clear. Like USB 2 to 3.0 jump was magnificently huge. Any jump after that is like meh. Because again, most people are still relying on data storage or something like this. Only now I can say we have reached a point where you can actually utilize the higher speeds. Because again, buy a latest and greatest printer, still has USB 2.0. Buy latest and greatest scanner, still 2.0. So, same pin count and same code gave us 10 Gbps. Now, like, how can you do that? If we needed to upgrade it, this is why. They wanted to make sure the legacy was intact and the extra pin was the playground. So, they upgraded the frequency, basically how quickly it was switching. It upgraded the frequency and the encoding protocol that was utilized, that was also upgraded. And on the same wire, same port, they got from same thing to 5 Gbps to 10. Now you can get this sort of thing. Same wire, same meaning you do not have to spend too much on the ports, do not have to spend too much on the cable, cord, cortex, everything, and you're gonna get double the speed. And this is a big jump, meaning let that be very clear. You can buy this and you can enjoy this. Like how big is this? You can do video editing on the drive itself. You can buy 10 GB, by the way, iPhone supports that. So iPhone, because they allow ProRes recording, ProRes is so huge that internal memory will fill up in minutes. So they're like, okay, directly plug a SSD and edit on it. Basically dump the video footage directly on it, record on it. And you pull it out, dump it in your computer, tada, you can utilize that. And USB-C is optional here. It's not mandatory, it's optional, meaning you can have USB-A that has 10 Gbps. And again, a lot of people have this inherent misunderstanding that USB-C is needed for 10 Gbps. No, like this sort of device will also work. It's just that what's the point of it, but it will work. Meaning if I have a lot of USB-C receptacles, but my motherboard has a lot of ports that are 10 Gbps and type A, I can buy type A to USB-C and it will work. So that is a doable thing. So USB-C is not mandatory, but there are a lot of devices that have USB-C. It's low cost because again, iPhones are also doing it, which is ironic. iPhone were the last company to come to USB 3.0 and they directly jumped. They're like, okay, we're not going to go to 5 Gbps, we're going to go to 10 Gbps. And so far, I have not seen any Android that has 10 Gbps handshake, only 5. Heck, even my S23 Fan Edition has USB 3.0. Surprisingly difficult to get USB 3.0 on Androids. Even on Apple, only recent Apples have that. So it's very difficult. At least Samsung S series always had that. Some flagship of some smartphones have that. I think Asus ROG phones had that, but it's very rare. So most of the time you're gonna get that. And be mindful, if you connect your smartphone and you're like, okay, now I'm gonna dump all the camera roll, it won't work very fast. Why? The flash chip on your mobile phone generally will only go to like 200 to 250. They will not put like, this sort of, or definitely not a full size NVMe speed. So be realistic about it. So this is 5 to 10 Gbps that most people have right now, and you do not have to worry too much about it because again, almost everything is backwards compatible with the hardware of USB 3.0. Now we come to 20 or 40 Gbps, which you can for simplicity just call USB 4. And for more speed, we wanted more conductors. But again, we had already changed the port. So people was like, okay, we're not gonna use USB-A or FAT micro cable. Meaning if somebody says motherboard is there and it has USB-A port and it etched 20 Gbps next to it, yeah, it's lying. It cannot be. Physically, it cannot because it does not have enough conductor. So this was created, basically USB-C. And again, USB-C was designed in such a way with forward compatibility in mind that it has dual high-speed parallel channels, meaning you have D plus D minus, which is your USB 2.0, one differential pair, base, integral, every mobile phone has this. This is a legacy and they will not touch it or tamper with it. Cool, awesome. You have V bus, your voltage rails, ground, cool, awesome. CC and sub 1, those are done for handshaking, cool, awesome. What about the extra pins? Now this is where it's interesting. It has RX plus and RX minus and TX plus and TX minus. They are transmit differential pair and receive differential pair, meaning now you have extra pair. For example, if I want to go from 10 Gbps to 20 Gbps, the cable has to become thick because now it has one extra differential pair. Basically, super speed data lane number 1, super speed data lane number 2. Now like, okay, doesn't this have 24 pins? No, it only has 12. For symmetry reason, they have that. It's like the wiring wise, it's only 12 wires that you have to deal with. But from a symmetrical point, so you can plug like this and like this, they design it in such a way that you have double the copper. So that's why they always read in this number A1, A2, A3, A4, A5, A12, and on the same side B12, B11, B10, B9, B8, B7, it goes backwards. So it's by design, let that be clear. So always look at the one half of it, then it will make sense. So you have USB 2.0 data, USB 3.0 and USB 4.0. So for 4.0 you do need extra pair of wire that does plus and minus. That's why it will only come and only support USB-C on both ends. Meaning you cannot have like, okay, USB-C on one end and USB-A. No, it has to C to C. Only then it will work. So that's there. Although we reached a point where to increase the speed from 20 to 40, it reached a point. They're not going to add more pins. What can do? Increase the switching speed. Cool. But now the cable becomes like an antenna. It's finicky, touchy subjects. It's not stable. Meaning when you buy a printer, they generally come with long cable. Why? It's USB 2.0. You do not have to worry about it. You can get a decent kind of length cable at USB 3.0, but the moment you touch 20, the cable length is this. Why? It has no integrated circuit. It's just copper to copper. You cannot have long copper because it behaves like an antenna. So, and again, at 40 Gbps, you can't even have copper cable. You have to have coaxial cable. It's like a radio antenna cable you have to have in order to transmit cable. I've linked a CAT scan of Apple's cable. Adam Savage did that with CAT scan and all that. It's fun. You should check into that. It is necessary requirement for long, high-speed cables. So passive cable will always be under 1 foot, and any length that you are buying like 2 meters or 4 meters generally requires a retimer chip, meaning there is a whole circuitry like an actual computer that takes all the signal that is weak and pathetic and that it amplifies it. And like, wait a minute, does that mean the cable itself consumes energy? Yes. Yes, it does. Yes, it does. Again, 20 Gbps, you don't need it, but if you want long cable, you need it. And 40, it don't even trust it. So it has to have that. And again, I used to see this in like 2018 or 19, this started to hit the market. Again, that was developer. I was like, how the heck you gonna put it inside a cable? Now you can buy it. So you have to have that. And this has generally been there in all the new laptops. Basically, if you have bought anything in recent year, as in like anything after 2020, generally has one port or maybe multiple port of 20 or 40 Gbps. And the big change that happened is that there was a parallel competitive, competitive market against USB, that was Thunderbolt. Intel made Thunderbolt, Apple implemented it. Apple sells a lot, but they do not sell that much. So Intel was stuck in a position where they were making this interface, they were making some money of it, but not that much. Apple wanted to make devices for it, but again, they are limited. How much they're going to make? They make the computer, they are not going to make card reader and everything else for it. So that created a paradox. So Intel, I think in 2017-18, they decided to open Thunderbolt 3 to USB association. Basically, take my development, copy paste it into your system. That created what we call USB 4. So Thunderbolt 3 is USB 4. They're like, okay, what is Thunderbolt 4? Same thing. It's just that they tightened the noose. In Thunderbolt 3, there was a lot of wiggle room. In Thunderbolt 4, same technology, they just tightened everything. It's like, no, it has to do this. So you can have Thunderbolt 3, it will work. You can have Thunderbolt 4, it will work. So Thunderbolt is the same as USB 4. And it's just, if you want to have a scenario where it's like you're damn sure that things work, just buy Thunderbolt 4. If a basically laptop says it's Thunderbolt 4 port, more chances are there that they have actually tested and validated. If it says USB 4, oh, by the way, there was a glitch, not even a glitch, I would say, like more of a limitation, because they wanted to make sure USB 4 was supported by mobile phones. 20 Gbps is still available in USB 4. But I'm like, why? Why? So yeah, it's a mess. Let that be very clear. It's a mess. And again, anytime you want like, hey, I want this device, cool, awesome, and make sure the cable is short, or if it's a long cable, it's an active cable that has an actual microchip in it. Retimer chip is the technical name. Without it, it will just not work. If you want your life to be easier, just buy everything that says Thunderbolt 4 and hope it's not cheap Chinese clone. Because again, if they do not have the retimer chip, it will not work. And it will down handshake, meaning it will try to do handshake. It will first try 40 Gbps. Let's say if all devices are supported, 40 Gbps, unstable, down clock 20 Gbps, down clock to 20 Gbps, 10 Gbps. It might work. So you might actually have a good experience, but you may not be getting the full experience. So I would suggest if you are buying this, buy from some place where you can return it. So if it's not working, you can return it. Now we come to the naughty part where this went all to poo-poo, which is cable and ports. Because you have, at this sort of speed, it's finicky. Heck, 10 Gbps is finicky. For example, this device technically should give me 10 Gbps. It was not stable for some reason. Turns out the cable has won. And again, it's a USB-C. It's not like I have used it 10,000 times. It's not that. It's just, it's finicky. All of this is very finicky, very finicky. So that creates a frustrating experience. And long cables flat out, it's very difficult. Now, do I need a long cable? Yes. For this camera, I can utilize this camera as a webcam. For that reason, I needed a long cable because this is my TV where I do the live stream and the camera stays here. The desktop is there. So that I required a long cable. I bought a 3-meter long cable and it does work. And it does do handshake at 10 Gbps, which was shocking to me. It's like, dang, it's actually stable at that. But again, of course, it can't do 20. So if I want this to be connected 3 meters far away, it will not. So that's the thing that you have to deal with. Basically, 20 Gbps, the moment you want to reach that 2 gigabytes per second, you have to get an active cable. And active has this issue that we call it e-marker chip, but not all e-marker chip are the same because of power delivery. So you could buy a system that says like, e-marker chip, but it's power handshake, meaning power delivery. That's why USB-C was designed by 2 people. One for data people, one was for charger people. So charger people are like, okay, how do we make sure that your charger does not blow up the cable? Let's say your mobile can do handshake, your charger can do handshake, cool. What about the cable? So cable has a chip inside it. If you do not have a chip, for example, this is a 20 Gbps cable. If I plug this to a device, it will only allow 60 watts of power to go from here to there. Why? It will understand there is no e-chip in this, meaning it is 3 amps only. It can go maximum of 24 volts. So you have to have an e-marker chip. There are 2 generations of e-marker chip. First generation was USB power delivery 3, I think. That allows you to handshake upwards of 5 amps. So that can give you 100 or 130 watts in some voltages. And then they created a new rule that is being worked on right now, European Union, that is by 2027, all laptop must support full-fledged USB 3. Power delivery 3.1. That requires a new e-chip. That e-chip can support 48 volt at 5 amps. Now, like, wait a minute, why didn't they increase the amps? They wanted to make sure the cable remains this thick. If they had increased the amp, the cable would have become like, copper is expensive. So they're like, okay, increase the voltage. And that is the upper limit. They can't increase above a 48 volt simply because once you touch 50 volt, it is classified as live wire, meaning touching it, the voltage can jump inside you, meaning your skin will not be able to stop it. So that is the upper limit. So we have reached the maximum point of USB power delivery, but again, requires a lot of e-chips. You have to buy e-marker chip. So it's a very confusing thing. Many times you could buy a cable from branded and you're like, hey, it looks good and it has e-marker chip, it will work at 20 Gbps. Not necessarily. If the e-marker is for power, it will work for power. So again, at least I'm happy that USB implementation forum is like, okay, just have the full thing saying like 240 watt and 40 Gbps. Then it should do both of them. And I would flat out recommend, if you're buying this sort of thing, please buy from a place where you can return it if it does not turn out. Like this is my motherboard ports, so to say. So it has 2 USB-A that is 10 Gbps. Oh, sorry, 3 that is 10 Gbps. One that is USB-C, one USB-C that is 20 Gbps. So this device, I have only one port that can support it. So this sort of thing, or every other port is USB 5 Gbps, which again, more than fast enough for almost everything. So let there be very clear, cable and port, and you have to be damn sure. Like for example, if I connected this to other ports, it will not work at full speed. So I cannot blame the device. I have to be damn sure that my port are correct, and then I have to be damn sure why my basically the cable itself is correct. And that's why Apple Thunderbolt 4 cable, it's freaking 16,000 rupees. It's like $120 or $150. And again, it makes sense. It's how many? 3 meter. It has a retimer chip, and again, this is what people cut it open, and it's like, yeah, there is an actual computer there to do that. Again, this is also claiming USB implementation forum certification, but again, how much do you trust it? So it's a messy thing. Let that be very clear. It's a messy thing. If you really want 20 Gbps or 40 Gbps, it's gonna be a mess. Power cable will become cheap because again, the moment the law becomes abiding, it will start to flood in the market. So that's not an issue. The data cable will be an issue because that requires a retimer chip, not just a handshake chip. It's like, bro, amplify the signal. Now, the most important, but caution. It is a messy thing. Let that be very clear. So you have to be sure of the whole goddamn chain. Like, what is your data metric? For example, in my Sony camera, there is a CFast Type A card. Now, CFast Type A cards can only go maximum of 2 gigabytes per second. So if I put this in a card reader that is 40 gigabytes per second, it will not work. It's like, I have to be sure, like, is the card reader, and again, that's the link speed. What's the reality speed? Reality speed card is only 1800 Mbps, meaning USB 20 Gbps should be fine. Anything more than that is just, I'm wasting time. So you have to be damn sure of the data storage, port as in like both end, and the cable, because again, if the cable is not there, then the device, everything has to be sorted. For example, I was very hopeful with this A7C Mark 5, A7 Mark 5, that I would not require to buy a memory card reader, because again, CFast Type A is a finicky card, expensive card readers. I was like, hey, the camera says it has 10 Gbps handshake. My computer has 10 Gbps port. What if it can copy paste files, video files, which are huge? It's like the video that I'm recording right now is generally give or take 60 gigabytes. So if it can dump 1 gigabyte per second, I would be fine. I would be fine. That's like 1 minute, 2 minute maximum. And turns out it's not. It only goes to 500. So I'm very disappointed. That's the CPU that is being the bottleneck. Basically, the SoC on the camera is like, it's like, it almost feels like Sony designed a 3.0 USB, like 5 Gbps circuit, and they're like, it does not look cool in the spec sheets. What if it doubled it? It's like, you don't have the speed support. It's like, what's the point of that? And again, this is the, because this all becomes so messy that you have to understand. If you have a hard drive, get a USB to 3.0, do not worry anything about more than that. It's like, that's 600 megabytes per second, you cannot exceed it. If you want to touch 40 Gbps, you have to have NVMe, and be mindful, if you're touching 40 Gbps, please buy NVMe that is from PCI 4.0, not 3.0. There are a lot of 3.0 in the market that are very cheap, but you will be, if you're buying that, buy the 10 Gbps one or 20, not 40. 40, it will not be utilized fully. So, oh, and be mindful, 40 Gbps right now is very early stage, so it's very hot. They require cooling fan and may not be stable because of thermal throttling. So, I would say if you really want high speed, 20 Gbps is the sweet spot right now. 10 is surprisingly cheap. If you want something on cheap, you can get that. 20, not too difficult. And again, you also have to have port. Like my hyper expensive motherboard does only has a 20 Gbps one port. If I want 40 Gbps port, I have to buy a Thunderbolt card. It's expensive AF. So be mindful of that. Like that's why you be mindful of that. However, I said that USB 4 is now useful because of this card, which is CFast Compact Flash Association Express card. It's NVMe made in a card format, and it's used by every camera company. You have Nikon, Canon, Sony's FX line of large cameras, all of that. Everybody uses that. And these, because again, we are recording higher bit rate and all that, the file size are bonkers. Like God help you if you are recording in Blackmagic. Those can easily be 1 terabyte an hour or even more than that. So you need to dump that file. If you are like, okay, yeah, I started copying file and it will take like freaking 1 day to dump it. It's going to be too slow. So 40 Gbps now makes sense. Like you can actually do it. And there is another advantage that is available. Not recommended, but it is doable, that you can dump the card, do video editing on it directly, because it is fast enough. It is fast enough at that point in time. You can say like, this is a pro grade card. This is CFast Type, CFast 4.0. This can easily read at 3500 Mbps and write at 1500. Write is a bit slow on this one, but I'm pretty sure you can buy a recent one that write speed is also very high, as in like some of them have write speed of 3200. Write will always be a bit slower than read. Yeah. So These are basically NVMe SSD, PCI NVMe SSD, so they can actually utilize the full speed. So that's the first time where you have a consumer device that truly utilizes 4.0, not just like, okay, I have a RAID array, then I'm like, use network if you have RAID array. And like daisy chaining, that was the main selling point of Thunderbolt, but I was like, what's the point of it? So that sort of thing. And let this be very clear, you do not know how the handshake is going on. You could have worst case scenario, you plug the device that's supposed to be 40 Gbps on a cable that's supposed to be 40 Gbps, you're on a port that is 40 Gbps, but software is not working. How would you know? Install USB tree view.exe. This is a handshake checker device, meaning it, for example, this camera I connected it shows Sony, manufacturer string Sony, product string A7M Mark 5, serial number is there, USB version, the critical part, 10 Gbps, port version, what is the port speed? So port is 10 Gbps, device maximum speed 20, and again device connection speed. Now, because again, port speed is shared by a handshake. It's like, hey, it talks to, I need this. Now, like, why does handshake has to tell that? So Microsoft can load the driver. And not to mention, the moment I switch the camera into live webcam, it downclocks it to 5 Gbps. That's why I'm pretty damn sure that 10 Gbps is just a handshake. It does not actually have the hardware to, like, power to actually utilize it. So that was very underwhelming. Like, I really do not, again, it's good enough for my case, but like, bit underwhelmed. It's like, bro, come on. I would have been pissed if it was USB 2.0, but like, underwhelmed, let's just put it that way. So you, and again, this is how I can verify, like, hey, I connected it to port, because it will say port maximum speed 20 Gbps, device connection speed 20 Gbps, device connection speed 20 Gbps. So then you can do that. And by the way, all modern motherboards can actually measure the current that is going into your device. So this actually says demanded current 0 milliamp, the battery was fully charged. So I would definitely urge you to look into this sort of device. That will help, software, sorry, that will help you to understand what the hell is going on, how the handshake is happening. Like, is the driver being loaded? Because sometimes you could have a scenario where the driver was not working properly and you will never know it. So be mindful. It is a finicky world that we are living in. We should not be living in this world, but it is what it is. So this was my presentation on basically the USB in the 2026. It's a mess. So hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.